This project is my neural network project that I've been playing with neural networks, and for this I've been trying to teach it to play Snake or have it learn to play Snake, whatever you want to say. So initially I started off with a using backpropagation, where I tell it what are good and bad moves, or what are good and bad sets of moves. So initially, if it ate the apple, that was good. If it died, that was bad. That was the only thing. That was if it's the only two moves I did, and then I had a it would reward every move between apples or death. So from the start of the game to the first apple it's eaten, if it ate the apple, it would positively reward all of those moves. And then if it died, it would negatively reward all those moves. And then if it ate the apple, it would stop recording the moves and move on to it would make its next decisions. And I used a exploration versus exploitation sort of thing for that. So I mean just the simple like the randomness into the less randomness. And then here, and then I switched over to a genetic model. Genetics usually take longer to train, but are often much better and much more accurate. And here I'm actually just simply going to I can actually just make, I believe this is the correct function the correct one to run. We run snake, and here this is the SFML window to display the snakes what it's learned. Down here, this is the generation number, the best score the generation has had, and you will see this number progressively go up for the most part. And this is a 4x4 snake game, which is very small, but it needs to be small to train quickly, to train in a reasonable time, because I give the neural network the entire game board, not just whether the food is above, below, left, or the right, or if there's danger above, below, left, or the right. And so yes, that's how I did it. And then it's even bigger than the 4x4 board. So I'm actually currently giving it 7x7, like a 7x7 grid effectively. And I'm keeping the head of the snake at the center. So the head is always in the center. So it doesn't have to make moves. It doesn't have to find the head and make moves relative to the head. It can just make moves relative to the center of its input, which will never change. So I thought that would train better. I haven't tried the other way. It might be better. I don't know. But as you can see, the best score is 160. Oh yeah, and it's playing 100 games. So right here, it's playing 100 games. So that's why it's giving giving way more than a 16 would. So we've got the main file, which runs the way I have it set up. I have a network class, and the network class takes a double function pointer that takes a reference to model. This is what the user would define to. This is the scoring function that basically returns this number. So this function returns these numbers, and then the network will choose the one that has the best score. So the user can easily create a function that determines score, that runs the tests. It has complete control of the network if it wants to. So it's supposed to make it really easy. And then once you've defined your function, you create a genetic model. You give it the size of the genetic model. So here we have the board size of the game, which is going to be that 7x7. And then you have the 4 outputs for up, down, left, and right. This would be the snake's decision. Here you have 1. What is this 1? Let's see. Let's see. What does this 1 do? What will it tell us? Hello? Okay, we're just gonna go to we're going to go to definition and your genetic model. Oh, the number of threads. That's right. So I think I'm gonna get rid of this, and I'm gonna implement CUDA into this program. And then here's the function that you will pass to basically the scoring function, and you are able to change it. So I mean, it doesn't have to stay the same, but as you can see, the score's certainly gotten better. It's had a maximum score of 207, and it started at a measly 112. So this snake neural network has certainly gotten better. And one thing I will say during this project is you certainly want to not use the standard library vectors because they are slow. Oh my program increased tenfolds when I created my own vector, or not my own vector, my own array. That's what this array is. So it's a very simple class, very straightforward, just a dynamic array class. You can add items, get the size of it, that sort of stuff. So very simple. Once this hits 100 games, it will actually display. This will turn into an actual window and not just a blank. So I'm gonna let it play. I can't speed it up, or I can't speed it up right now. So later I will, and I want to make this better. I want to make it faster, and I want to train it on a much larger grid. So that's going to take more researching into actual neural networks. But this is very simple, very basic, but it was very fun. Also, this is my biggest project yet. So we do clock, which counts how many lines of code there are, 1,600, 300. It's not huge, but that's the most I've ever written. And you also have to remember I have a lot of commented out code. So this is nowhere near finished. I'm nowhere near done with this. This is so much fun. Neural networks are amazing. I think neural networks are going to replace a lot of things in the future. Look at this. We had a big old jump from 206, 229, and then boom, we went up 20. So we're at 250 now. So we're at 1/8 perfection. So I'm just going to let it train, and at generation 100, this will start displaying stuff. So it's it, sorry, it is done. It's and by done I mean this is not very good. It it only hit an average of 400, which is pretty much 4 out of 16 per game. It has certainly gotten better. I've seen it been. It's made perfect ones. It's made consistently perfect ones, where it'll play 10,000 games in a row and hit perfects every single time. So, like I said, it does take a lot longer. It does take a while. And the problem with genetic neural networks is that they're very random. It's all based on luck. It's all based on randomness. So if you get unlucky, it will take longer to run. It'll take longer to train. So I mean, it's yeah. It just that's the downside of them. But they usually are much better because using back propagation, I only ever got it to, I think 12 was the highest, and then with genetics, I've had perfect. So that's it for this.